everybody who is watching this video. I am Sir Olenjolai Singo from United Republic of Tanzania. So I'm a Tanzanian because that's what I'm not just from United Republic of Tanzania, but I'm also Tanzanian. I would like to welcome you into this fantastic YouTube channel that's called the Tanzania Online A-Level Secondary Schools in the square brackets Olenjolai. This is my official YouTube channel, and before I start the quick review of second session, I would like just to give you a brief introduction of this channel. In this channel, the main visions I would like to teach A-level students advanced mathematics, advanced chemistry, advanced physics, and basic applied mathematics. So that's the main visions. I want to have them according to the requirements of the syllabus. These materials might be used worldwide, everywhere in the world, in every continent can be used, because mechanics has been learned by different institutions and different secondary schools. But however, that my main focus will be on the syllabus of United Republic of Tanzania for A-level secondary educations. Okay, so that's the main vision. And the problem I'm solving is, it happens when I was in A-level schools or A-level studies. When I was studying A-level, myself and even my classmates, we had challenges on understanding different concepts on advanced physics, different concepts in advanced chemistry, in advanced mathematics, and even in basic applied mathematics. So we have been suffering and struggling a lot. Also, after my graduations, I have been teaching these 4 subjects that I'm teaching in this YouTube channel. So I've been meeting with many students, and they are in physical, in person. I was not using the digital technology by that time. In person, when I meet with those students, they have been experiencing a lot of problems, and even others, they are planning to run away from their school. Why? Because science is difficult for them, mathematics is difficult. They have a big vision to solve some real-life problems by using scientific and mathematical concepts, but now they have a lot of limitations, such as irresponsible teachers, and not even irresponsible teachers, even the materials themselves are very intensive. But one of the critical reasons, it's common that we experience, all of us, we have passed by this road, is having a good guidance that how should you start. Because you can start mechanics, you master it. When you go to heat, then you'll find that you forgot all the concepts of mechanics. But in case you have a good guidance, it means you'll start them in chunks. It means that in small portions of the time you have to cover this, and then next you have to cover this one, you come this way. So there are different techniques that I'll be sharing with you, not only teaching, but I'll give you many techniques. I'll be sharing many techniques that I've used myself to be successful in A-level. And not only I've been using on teaching students for 5 years, because I taught A-level students for 5 years from 2010 to 2014. Okay, and fantastically, I have touched the life and changed the life of almost 2,000 plus, means more than 2,000 students in United Republic of Tanzania. Okay, so that is the little introduction. So the methodology, I'll be recording the live lectures and then send by using the internet, so you can enjoy them anywhere, any time, and at any just I say that in free, or at a free cost. There's no any cost that you have to pay me in order to get these materials by this time. Okay, so that's the main thing, or the main concept of this one. So for you to stay tuned, because I'll be adding many videos in this YouTube channel. Make sure that you do at least these 5 steps. That number 1, you should have a receiving device, which is an electronic device. Number 2, you should have an email, because without an email you cannot sign in YouTube applications. Number 3, you should sign in YouTube applications. And then number 4, you have to subscribe, and just click the button, the software button that with the backgrounds of ready and have a text in white and subscribes. And then in case of the mobile phone, then it's done. If you click once, it's done. For the computer, then after you click that button, it will be going to change its color to gray, and then the bell will appear there. So make sure that you click the bells and choose the first option, that is called all. So the YouTube community will give you official notifications at any time, anywhere, whenever that I add a new video in this YouTube channel. So if you do that, I believe you will enjoy. Again, just the last point for introductions about this channel. in case you will be looking for the groups of videos. When I say groups of videos, what does it mean? For example, the main topic here is mechanics. So I will take all the lectures or all the videos of mechanics and put them together in something we call in YouTube playlist. So when you go to my YouTube channel that called it Tanzania Online A-Level Secondary Schools in square bracket Olenjolai, then you have to go to the playlist, and then you'll be seeing the list of playlists that I've created and collect related videos. It will help you to get the sequence of videos. So that's all about the brief introductions of this YouTube channel. I believe that you enjoyed it, so I want now to take you into this business. So I'd like to give you a little intro of this session 2 or lecture 2. One point you have to know this: my God who had given me this business is serious, and even myself as a teacher, I'm very serious, and the whole programs, we are very serious on this, and we are very committed. So these programs is not for the lazy students, so you have to be serious. It's a serious business. We need serious people, and if you be serious, you'll benefit on these materials. This is not entertainment channel. This is, yes, it is entertainment in case of science and the mathematics, but in case of learnings, this is educational and even a serious educational and high-level educational system or channel. Okay, so make sure that you have all the required resources. You have an exercise book, you have your scientific calculator like this one. In case that you don't have any of them, please go to the descriptions of this video, then you'll see how you can order it online. Then I can ship it in any regions in United Republic of Tanzania. And even sometimes you can have a reference, a textbook like this one. This is called the principle or S&D principle of physics. So it's recommended in the syllabus of United Republic of Tanzania to be used for the A-level students. So you can have this book, or you can have even the other ones. So make sure you have all the materials just like you are in actual class. So then, the main topic that I'm going to teach you in this video is called mechanics. And then the topic which you are going to discuss, because mechanics has 11 topics, and number 6 is gravitation. Okay, the subtopic I'm going to teach you today is Newton's law of universal gravitation. That is lecture or session 2. In case that this is your first video that you made, please go to the first lecture in the same channel, and then you come back to the second lecture, because this is the continuations of what I've taught in the first lecture. In case you find that I'm going so fast, this is the advantage of the digital system. You can pause the video, you can watch it several times as well as you can, until the chorus of mechanics being clicked in your mind. I want you to like physics. That's the main objective of this channel. I want you to love science, and I want you to pursue your visions in science and even in mathematics. So, before I go to the lecture 2, I want to do a quick review of lecture 1, right? So lecture 1, the first session. In lecture 1, basically I have introduced you that I have done introductions of what the meanings of astronomy and where do we get the term gravitation. Then again, I've introduced you the concepts of gravitation, what the meanings of gravitation. And then we spend some time to discuss about astronomers' theories. Okay? Astronomers' theory. And in these astronomers' theories, we discussed the 3 of them. The first one, we discussed about the eccentric, how were we thinking about the sun and the other related bodies, such as the planets, the earth, and the moon. Okay, the eccentric, and then we learned about heliocentric. Okay, I'm just doing a quick review. Heliocentric theory, and then we learned about Brahe, right? So Brahe have the said astronomical theories. It was not enough. Again, I taught you about Kepler's laws, right? So I pronounce it Kepler's laws. Mr. Kepler's, the physicist, he introduced these 3 laws. The first law, we call it the law of orbit. So we have stated, and I taught you, and even just we have used the drawings of his thinking. And then the second law, we call it the law of area. We discussed in lecture 1, and also finally, before I ended that lecture, I told you about law of period, which is Kepler 30 law of the universe, right? So it was very fantastic. Today, I want to take you into the new and even a very interesting, and this is the heart of gravitation. And today I'm going to teach you in this lecture about Newton's law of universal gravitation. Say it, Newton's law of universal gravitation. That's what am I going to sing, and this is the name of the song in physics, right? So Newton's law, I know that you met with this man in many cases. Yes, he was a very intelligent man, okay, because he has been dealing with different sections of life. So I would like just to discuss with you. Possibly it might be the first time to hear. You didn't hear about this concept in O level. It's fine. I will be taking you step to step until you master this concept. So Newton's, he was the second, or yes, we call it, he was the next physicist who did the experiments observing about the universe after Kepler's. So I would like just to link this lecture with the first lecture. We say that about 50 years, about 50 years of Kepler's. After 50 years, means that about 50 years after Kepler's laws, right? Kepler's laws have been, I want to write this sentence because I want to link, has been announced. So Newton was there, and then he was quiet. Okay? Isaac Newton, Sir Isaac Newton. His name is Sir Isaac Newton. And to speak, frankly speaking, I would like to say that this is the one of very impressive physicist to me. I like him, okay, and I love him a lot, and I like his work, okay, and the way he used to think about the world and the problems. Isaac Newton showed that anybody, right, anybody or any particle, which moves about the sun, must be acted by the force. And this force, by the force, which is directed, this is Newton's observation, directed towards the center, right? Directed toward the center, okay? Towards the sun, center, or the sun, the center, yes, the center of the sun, okay, of the sun, to keep the planets in elliptical or circular, to keep the objective of this force, to keep the planet, right, to keep the planet in elliptical or circular motion, So let me explain in brief what I've written there, so that you can enjoy the beauty of physics. So, about 50 years of Kepler's law has been announced in the world. You remember I told you in the first lecture about Kepler's law. Sir Isaac Newton showed experimentally by using some the concept that we call that in logical reasonings or observational reasoning, that anybody or any particle which moves about the sun, it means circulate about the sun, must be acted by what? By the force which is directed, the direction of this force, toward the center of the sun to keep the planet, example the Earth, in elliptical or circular motion. What was the thinking of Sir Isaac Newton? First of all, he accepted all the three Kepler's laws. So he agreed that he didn't spend much of his time on observing about the motions of what of the planets, whether it's elliptical or circular like these other astronomers. So Kepler's helped him to tell everything concerning about it, that the planets are the ones that revolve the sun, and the sun is at one of the focus, right? And then law of areas, because remember Kepler, in the third law, in the first law, he spoke about the orbit, where the planets used to revolve about around the sun. And then in the second law, he has been discussed about the law of area, whereby the sun is not at the center, it's used to be in one of the focus, because there are the two focuses in elliptical motion. Then in the third law, he introduced the relationship between the periods of the revolving bodies, for example, the planets, and the distance, right, between the sun and the dark body that revolving around the sun, for example, the planet. So that's what we call the law of period, where we say that the square of the period is inversely or directly proportional? Directly proportional, right? Directly proportional to the cube root of the mean distance between the sun and the planet, right? So Newton now came with the thinking, okay, I agree that these planets revolving the sun in elliptical motions or in a circular motion, but what keeps them constantly? Because the issue is, how do they revolve around the sun constant? For example, the Earth complete one revolutions after 365 days. So then maybe for the first year, it's revolving by passing the same orbit. Second year, revolving about the second times through the same orbit. Third year, fourth year. So what is keeping them? That was the heart of Newton's investigations concerning about the universal. And I will be sharing to you step to step, and you'll get the answer of that question as long as we continue. So stay tuned. So that's what he said. So he said that, okay, Kepler, you told me that the planets are revolving the sun in elliptical motion. Okay? And then we say that, suppose that this is the center, and then this is the one of the focus, right? And then the focus, and the sun is here, right? It's fine. So suppose you have a planet. So this is the planet, let's say. And then this is what? The sun, right? The sun. This is the focus one. And then this is the second focus. This is the center, for example, right? So that's the sun, and this is the elliptical. So this is what an orbit of the planet. So what he said, he was doing experiment. What does it keep this planet to revolve in the same orbit continuously? After several years, it won't change. It used to pass this pass, right? So then that's what he has been experimenting, right? And then I want just to share with you. And then after doing a lot of experiments, then he finally introduced a law that we call Newton's law of universal gravitation, right? Fantastic. So then now, after I have given you that a little introductions and even a little way of thinking differently, I would like now to take you into the statement or Newton's law. So Newton's law, how do we state? Newton's law of universal gravitation. So if you, in your school you have Wi-Fi, it means that the wireless internet. Please use it effectively by using the school computers, because that's the main purpose, for learning purpose. And that's why even myself, I'm delivering this material everywhere, so you can enjoy them at any times and everywhere. Okay, gravitation. So Newton's law of universal gravitation. So the common questions in NET exams, in the midterm exams, in term exam, in annual exam, in mock exams is this one. You can be asked that state Newton's law of universal gravitation. Right? Universal gravitation. There are something we can call it Newton's law of universal gravitation or Newton's universal gravitational law. So depend. So then I will state this law by using two sentences, but they are closely similar because of the two resources that I found it in. We say that this law states that every particle, not every planet, every particle, say with me, every particle, not only the planet, every particle, very powerful law, every particle attracts what? Attracts every other particle, every other particle, right? Attract every other particle in the universe. Right? In the universe with a force. I'm stating the Newton's law of universal gravitation. With a force. The force that is directly proportional to the product, of their masses. Right? Of their masses. And inversely proportional. Inversely proportional. Right? The goodness of this law, we have also mathematical equation. So don't worry. Inversely proportional to the square of the distance. Right? Of the distance between their centers. Their centers of what? Of every particle, between their centers. So this is how Newton stated his own law of universal gravitation. Every particle, I don't want to underline because you can be tempted even yourself to underline. Every particle, is this a particle? Yes. So this particle right now, and myself, am I a particle? Yes. So there is a force of attraction between this ruler and me, because this is the particle and I'm a particle, right? So then how do we measure the magnitude of this force of attractions? Then Newton's continues. First of all, attract each other. So I and this ruler, we attract each other. That's number one. And then in the universe, we are on the universe with a force that is directly proportional to the product of their masses. Oh, fantastic. So the force, the magnitude of the force between this meter ruler and me, it will be directly proportional to my mass and the mass of this ruler. So the product is between my mass and the mass of the ruler. Again, he continued on his investigation, and inversely proportional to the square of the distances between their centers. So suppose this ruler, it is here, we have a force of attractions between ourselves, between me and this ruler. But we have a distance, a mean distance from the center of this ruler. We have a mean distance from the center of this ruler, and then have against to the mean distance of my center, right? So this distance should be square. So it means the force will be inversely proportional to the square of the distance between this ruler and me, right? So in case that the force, in order for the magnitude of the force to increase, it means that, because you know the meanings of inverse proportional, right? If the square of the distance is high, then the force becoming greater, becoming less, right? And becoming less. And then if it is small, then the force becoming larger, right? That's how the meanings of inverse proportional. So that the meaning. So the man here, he took a lot of different bodies, okay? And then, for example, that he just took a ruler and then measured the mass of the ruler by using the beam balance and the mass of the chalk by using the beam balance. He knew their masses. Then he found out the product, right? And then again, he measured the mean distance between the ear centers and find the square, right? After finding the square, then he did the simple mathematical operations of what? Division, dividing them. And then find that as this distance increases, or the masses of these particles increases, then the force is going, as this distance increases, then the force is going to be what? Increases, right? And then as the mass of these particles increases, then the force is going to increase. Understand that? So that's how. But it is not simple like the way I demonstrate. The man spent many years and long time on doing the experiments to demonstrate this. So don't think like it is just easy like eating a biscuit. No. Newton's laws, or a law to establish a law, is not easy like buying a biscuit and eating it. Again, I would like just to remind you, this is my Thanksgiving offering, right, to God, who has given me a gift of teaching, and teaching even millions of the students at the same time. So even for yourself, in case you feel in your heart to offer your Thanksgiving, please use this number, 255-759-745331. I would like to thank you in advance for your Thanksgiving, which will be used in paying the running cost for more videos of advanced physics, advanced chemistry, advanced mathematics, and best mathematics to be in air, right? So make sure that you keep this from your heart. It's not mandatory, right? I offer this that's why I offer free. So it's my offering. I offer my gift to God, not to you. Okay? Again, before I explain this law, in my finding, I found another form or another sentence stating this law. Excuse me. The class is busy. If you hear those sounds, mean that the class is at work. So he said that it is stated that, okay, the Newton's law of universal gravitation, everybody, right? Everybody in the universe should be where? In the universe. Remember the limitation, in the universe. That's why we call it Newton's law of universal. So those two bodies that are cutting each other should be in the universe, not outside of the universe. Remember that. Okay? Everybody, that is, we say everybody in the universe attracts what? Attracts every other body, okay? Every other body with a force. Right? With a force which is directly proportional to the product of the ear masses. Products of the ear masses, and inversely proportional to the square to the square of the distance between the ear centers. Of the distance between the ear centers. So this sentence does not have too much difference with the first one, but I want you to be aware in case in some of the references you find that they're using different sentences. Don't get confused. The point, you have to know the keyword in stating a law. So let me explain in brief, and then I have to continue. So it is stated that everybody in the universe attracts every other body with a force which is directly proportional to the products of the ear masses and inversely proportional to the square of the distance between the ear centers. Again, remember that I would like to speak this publicly, that I love physics. I like physics, I love physics. How about you? Ask yourself that questions and then tell me in the comment section. In case you have a question, please ask in the comment section. Don't hesitate to yourself. So I think that up to this moment, you know how to state Newton's laws of force universal gravitation, right? So now, let me take you to another point, another contributions of Newton. Then I want to teach you mathematical equation, right? Mathematical equation of Newton's law of universal gravitation. Okay? So Newton's again, because he was a mathematician, he was a physicist, he was a mathematician, he was a sociologist, and also he was also an astronomer. So this is his contributions in astronomy, right? The same person. How about you? Okay? So we say that from this Newton's law of universal gravitation, every particle attracts every other particle in the force with a force that is very proportional to the products of the ear masses. So we say that suppose the two particles of mass 1 and the mass 2 attracts each other where? In the universe. Right? In the universe. And then suppose again that the distance between the two particles is r. So what does it mean? Suppose that this is the first particle, we have mass 1. Again here we have another particle, we have mass 2. So then we say that, remember that this we call it the mean distance. I think that I should not, let me just follow the law. Suppose that this is the particle 1, here we have mass 1, and then this is particle 2, here we have mass 2, right? So then this is the center of the first particle, and this is the center of the second particle. So it means that we say that now, okay, so I think that, let me just be linearly. I would like to draw the straight line, okay? So then this is the mean distance between the centers of these two particles. So then this is the center for another particle, and this one we call Tm2, regardless of the ear size, regardless of the ear shape. So then we say that here, from this point to this point, this is the ear mean distance we call r. Then this is mass 1, this is mass 2. So according to the Newton experiments, what he found, there is a force of attractions. These two particles attract each other. So listen, it means a particle of mass 1, right? attracting a particle, is being attracted by a particle of 40 of mass 2. Listen carefully. So this is the direction of the force. So this one is being attracted by a particle 40 mass 2. So this one, this is the directions of 40 of force 2. Force due to the particle, secondly particle. So it means that just to simplify the concept, this is equal to F2. Again, mass 2 is being attracted by mass 1, right? In opposite direction. So this, we label it is what? F1. And this is the distance. So this, we'll be discussing the investigation of what happened to this force in opposite directions later. But I would like just to establish the mathematical equations and give you the mathematical equations of Newton's law of 40 of gravitation. Okay? I'm enjoying to teach you under the God's anointing. How about you? You enjoy to learn? Tell me in the comment section. And tell me if you understand what am I teaching you or don't understand at all. Okay. So we say that from this diagram, these two particles attract each other. Particle 1, particle 2. Regardless of the size, remember. But these two particles are in the universe. Right? So what is happening here? According to the Newton law, state that the force of attractions between these two particles is directly proportional to the product of their masses. It means if you take mass 1, you multiply with mass of the second particle. I get that force, so this is, let's say, the first statement. The second statement, I again say that this force is inversely proportional to the square of the mean distance. So this is equation 2, right? So that is, let's say that is the first step, and then this the second step of sketching, right? Okay, and then this the third step. Okay, we have sketched it. This the third step. Okay, of representing in mathematical form. So the first step right now, we say that substitute equation 2 in equation 1. So if you substitute equation 2 in equation 1, we say that the force of attraction between the two particles will be very proportional to the products of the mass 1 and mass 2, and inversely proportional to the square of the mean distances. Again, so you say that in mathematics, this proportionality constant, this is the proportionality, so replace this proportionality constant. So it means that the force of attraction, this will be equal to the proportionality constant K times mass 1 times mass 2 over square of the distance. Okay? But what is K? K is equal to G. And what the meanings of G? G is called the universal gravitational constant. So G is universal gravitational constant, which has been found and proved everywhere by Sir Isaac Newton. So now the mathematical equation of Newton's law of universal gravitation can be represented now in a fantastic way, that the force of attractions between the two particles or two bodies will be equal to the gravitational constant times mass of particle 1, mass of particle 2, and then over square of the distance, of the mean distance. Don't do this in exam, but I want just I put in the square bracket to give you a notification that this is very important equation. Okay? That's very important equation. So then I would like just to take a few minutes to discuss about about observation. Okay? Then we say that in observations of Newton's, okay, in the force of attraction. What did he discover? Force of attractions. So this force of attraction explaining something very important that Newton stated. So number one, the first observation that he found is this force of attractions is, first of all, the nature of the force is the force of attractions. There's no force of repulsions in the universe, or between the two bodies that is the universe. So he said that a body of mass, this one's attracted, a body of that one's by the gravitational force of this. So he said that the first observation, the nature of the force is between, so the nature of the force between two bodies is attraction force. Attraction force is not repulsion like in electrostatics. That's the first observation. Second observation, we say that a body or a particle, of mass 1 attracts what? Attracts a body or particle of mass 2 by what? By the force. Remember that the force, according to the concepts of vector, force is a vector quantity. So the force has both magnitude and direction. So a body of particle 1, this particle 1, attracting the second particle by what? By the force labeled as what? F1. And they also simultaneously, right? Simultaneously, a body of mass 2 attracts what? Attracts a particle. So this is the particle, a particle of mass 1 by the force which is labeled in this figure as F1. This is F1, F2, right? But what you observe in these forces, they are in opposite direction. So we say that this attraction force is in opposite direction. So in opposite direction. Okay, that's the how. So in opposite direction. Opposite direction. So that is one of the findings of the observations. Okay? So we say that this force is in opposite direction. So because the forces are in opposite direction, so we can say that F1 now, right? F1 is positive, and then F2 is in opposite direction, is negative, right? So that's how we call it. So even sometimes we don't introduce a negative signs in the mathematical equations, but you have to note that. Okay? So that's the second observation. Again, we say that the said observations, according to the Newtons, everybody attracts each other. Said observation, we say that the said observation, because everybody attracts each other, because everybody attracts each other, everybody in the universe attracts each other, then Newton introduced the gravitational, introduce the gravitational universal gravitational constant. So introduce the universal gravitational constant, the purposeful gravitational constant. And this gravitational constant in physics you use the capital letter G. Why? To encounter the force of attractions between small bodies. To encounter the force of what? The force of attraction. The force of attraction between small bodies. So that's what Newton did. He said, okay, this star is attracting this one. But these are the small bodies. If you measure their masses, it is very small. Right? So in order to encounter the force of attractions between these two small bodies, then Newton did a lot of experience and finally said, okay, I know how can I answer these questions. Then introduced the gravitational constant in mathematical equation. Right? So that the third observations of Newton's law, because of Newton's in the force of attraction. Newton's in force of attraction. So again, there you see a new terminology, right? And this new terminology is called the gravitational constant, universal gravitational constant. I would like to spend a few minutes to teach you the meaning of universal